Okay, now we are moving on to 5.2. This is page sorry, my Apple Pencil needs to be reconnected. And there. So this is page 175. And they're looking for degree. They're asking us to write the expression in terms of the degree from the biggest degree going first. So I need to give you the definition of a degree in a term. Degree in each or a term. So a term is going to be an expressions that involve both coefficient and variable. So 2xy is a term. 2x squared plus y squared is two terms. So this is one term, the first term, and this is the second term. So each term is separated by a plus or minus. Each term is separated by a plus or minus. For example, I can also have xy squared minus 3x plus 5. So there are three terms here. That's the first term, second term, and the third term. So my first term here is xy squared. My second term is negative 3xy. So you need to know that the sign always belongs to the term right after it. Sign belongs to the term right after the sign. The sign is just a plus or minus, right? That's why this is a negative 3x for the second term. And the last term here is just a 5, just a positive 5. Usually when it's positive, we don't even write out the positive. So now that you know what is a term, you can use these examples again. So these three are just algebra expressions. Okay, xy squared minus 3x plus 5. The degree will just be the sum. So I should say degree of each term equals to the sum of the variable exponents in each term. So for 2xy, the degree here is just going to be 1 plus 1. Because there's x to the power of 1, y to the power of 1, we just don't write out the 1 here. They're invisible. So the degree is 2. For 2x squared plus y squared, the degree of 2x squared equals to 2. Just a variable exponent here. We only have one variable exponent. And the degree of the second term, y squared, is also 2. Right? Again, just a variable exponent here. And then we have xy squared minus 3x plus 5. So degree of xy squared is going to be 1 plus 2, which is 3. Again, it's x to the power of 1 and then y to the power of 2. So we need to add it up, including the invisible 1. 1 plus 2 is 3. For negative 3x, the degree will just be 1. Just x to the power of 1. And then finally, the degree of our positive 5 will be 0 because there's no variable. Degree is the sum of the variable exponents. Okay, so now with those definitions in mind, we can go ahead and do question 1. 6xy minus 3xy squared. So I can say that the degree for the first term is 2, because 1 plus 1 is 2, is x to the power of 1, y to the power of 1. The degree of the second term is x to the power of 1 and then y to the power of 2. So if you add it up, you get 3. You add up the variable exponents. So now I can rearrange them. I want to have the highest degree term first. So negative 3xy squared, that's the higher one with a degree of 3, plus 6xy. So there's always an invisible positive here. We just don't write it out whenever we don't. Whenever we can choose not to write out the positive, we will try not to write it out. So that's why there's nothing here, but we all know that it's positive 6xy. But here I have to be more specific and write out positive 6xy. If I don't write anything, then other people would think that we are timesing here. When there's nothing in between them, in math, it's gonna be times. Okay, so that's 1a, and then 1b. 3a minus 8b minus 5a plus 2b plus 3. Oops, I wrote down the wrong question. This is 2b. 1b is u squared plus 2w to the power 5 minus u squared w4 minus 3. So again, I need to write down the degree first. This one is just 2 u squared. This one is w to the power 5, so the degree is 5. This one we have u squared w4, so we add the exponent. 2 plus 4 is 6. And this one has no variable, so the degree will be 0. Once again, we want to have the highest degree term going first. So this will be negative u squared w4. Again, the sign always belongs to the term right after it. That's why it's negative u squared w4 plus 2w to the power 5 plus u squared minus 3. And that's it for 1b. 1c. Negative a to the power 4 plus 2a squared b to the power 3 plus 6ab to the power 3 plus 2a minus b minus 1. The first term has a degree of 4. Second term has a degree of 5. You just add the variable exponent. Third term has a degree of 4. It will be a to the power of 1 times b to the power of 3. So 1 plus 3 is 4. This is just 2a to the power of 1. So the variable exponent is just 1. Same with b. And negative 1 has no variable. So we have 2a squared b3 going first. Now, the second term, I'm debating between these two. They both have a degree of 4. So when that's the case, we go according to the alphabet. This one has more a compared to b's because a is before b's in the alphabet. So a will go first. So negative a4 is going first, and then plus 6ab to the power 3. And then same idea here. They have the same degree, 2a and negative b. Because a is before b in the alphabet, so a is going to go first. 2a minus b, and then minus 1. And there, that's the answer for 1c. 1d. X to the power 3 y minus x squared y to the power 3 plus xy squared minus 3. So the first term has a degree of 4, second term has a degree of 5, third term has a degree of 3, and the last term has no degree. So negative x squared y3 going first, plus x3y going second, and then plus xy squared, finally negative 3. Now I just realized that I didn't answer the entire question. They are also asking for the degree of the polynomial. So degree of the entire, so the whole thing, these are called polynomial, is equal, or I can just say that equals to the highest degree term. So in 1a, the highest degree term is 3, so the degree here is going to be 3, the degree of the entire polynomial. In 1b, the highest degree term is 6, so the degree of the entire polynomial is 6. 1c, highest degree term is 5, so the entire one for the entire polynomial is 5, and for 1D as well, the highest degree term is 5. So for the entire polynomial, the degree is going to be 5. And that's it for question 1. I will see you in question 2.